All right, last example video for the chapter 9 confidence intervals for proportions. All right, so this one we do actually have a scenario. Here's what we're looking at. It says a survey of 1,000 college seniors working towards an undergraduate degree was conducted. Of the 1,000 surveyed, 650 stated that they were planning to pursue a graduate degree. Construct and interpret a 96% confidence interval for the proportion of college seniors who are planning to pursue a graduate degree. All right, let's go ahead and go through our steps. All right, first thing that we need to do is we need to come up with our point estimate. All right, so our point estimate here we go. First off, 650 out of my 1,000 people that I surveyed, my sample, said that they wanted to pursue a graduate degree of some sort. So 650 divided by 1,000, that is right at 65%. That is our point estimate. All right, so I'll go ahead and put 65% right in the middle of our nice normal model. All right, now here we go. Let's talk about what we want our confidence to be. Kind of a weird one here. We've got 96% confidence. All right. We'll go with it. All right, 96% confidence. So let's talk about how much is left for my ends, and then we'll find those critical z-scores. All right, so 96% confidence. That means that we have 4% left for my tails, and if I have 4% left for both tails, that means that I have 2% on each tail. That would add up to 100%. We have a normal distributions are symmetric, so that 4% is half and half. All right, so we need to figure out our critical z values. How many standard deviations below are we subtracting? And then how many are we adding? All right, so here we go, Desmos. Let's see what you got for us. All right, don't forget, this is a normal distribution. I'm going to go ahead and define it just as A. All right, and I'm looking for inverse CDF. A is my normal distribution. And looking at this, we wanted 2%, so 0.02. So this is going to be negative 2.05 standard deviations. So this is negative 2.05 standard deviations below. And because this is symmetric, this means that there's going to be positive 2.05 standard deviations this direction. Wonderful. All right, so here we go. We know we're centered at 65%. I want to go 2.05 standard deviations up, 2.05 standard deviations below. All right, now what is a standard deviation in this problem? Well, let's talk about our standard deviation in this problem. All right, using our formula, here we go. We have 65% of those surveyed that said that they were going to have pursue a graduate degree, which means that 35% said that they didn't. And then finally, we're going to go ahead and divide by our sample size. Make sure you choose the correct number. Our sample size was 1,000. We had 1,000 total people that were sampled. And if I were to calculate this out, just to get an idea of what we're looking at for our standard deviation, times 0.35, and then that's divided by 1,000. Very small standard deviation, only about 1.5%. So a pretty small standard deviation, but that goes along with our pretty big sample size as well. So this is right around 0.015. All right, now we are ready to make our we're ready to go ahead and make our confidence interval. All right, so here we go. Oh, you're not going to be able to see that. That's ridiculous. All right, let me go ahead and go with a larger font size. All right, so our original guess was 65%. I need to subtract away 2.05 standard deviations, and a standard deviation is only about 1.5%, so 0.015. And I'll go ahead and type it out while we're at it. For our upper bound, it's the exact same thing. We are simply adding instead. All right, so I'm going to kind of cheat if that's okay with you, just to kind of help with some accuracy. 0.65. We're going to go ahead and subtract 2.05 standard deviations. And my lower bound is right around 61.9%. So that is, oops, 0.619. And if I change this to addition, my upper bound is right around 68.1%. 68.1%. 68.1%. All right, so what does this mean in the grand scheme of things? What does this mean? Well, we only took a sample. We did not survey every single college senior and ask them whether or not they were planning on getting a graduate degree. But here's what we can conclude, that I am 96% confident that the true proportion of college seniors that are pursuing a graduate degree is between 0.619 and 0.681. We did not survey every single college senior. However, with our sample and our confidence interval, we're about 96% confident that the true proportion, the actual proportion that is going on to get a graduate degree, is going to be somewhere between about 62% and 68%. All right, I hope that helps you out. If you made it all the way to the end of the video, I am offering extra credit if you simply email me your favorite dessert. I know that seems silly, but I want to reward the people who are actually watching these videos. So, extra credit, simply email me your favorite dessert. Feel free to send a picture too. I'm looking for things to bake over this nice, wonderful quarantine. I hope you guys have a wonderful day. Please email me if you have any questions.